The vycon VDC flywheel energy storage system is a critical component of the continuous power system used in mission-critical applications that require uninterrupted power in the event of a utility outage. Components of a continuous power system include an uninterruptible power system, often referred to as a UPS, which provides conditioned power to the critical load, the utility supply, which is the primary power source, a standby generator that provides long-term backup power during a utility outage and is considered the secondary power source, an automatic transfer switch, referred to as the ATS, that switches the power source to the UPS from the primary source to the secondary source and back, and the flywheel energy storage system that provides the short-term backup power during the time that the primary source is lost until the secondary source is available. The flywheel energy storage system, the vycon VDC, is comprised of a bidirectional converter and the flywheel energy storage module. The system is controlled and is monitored locally via a graphical user interface which has remote monitoring capabilities. This simplified one-line diagram demonstrates the operational sequence of the continuous power system when utilizing vycon's flywheel energy storage system. In normal operation, power for the critical load is supplied from the utility source. For three-phase power applications in the United States, this is typically at 480 VAC. The utility source feeds into the primary source side of the ATS. The purpose of the ATS is to 1. Detect a loss of power from the utility source in order to provide a start signal to the standby diesel generator, and 2. Provide a mechanical switchover from the primary power source to the secondary power source. As shown during normal utility operation, the output of the ATS is fed into the UPS where the power is rectified from AC to DC and then converted from DC back to a clean, regulated AC voltage that is delivered to the critical load. The vycon VDC connects to the DC bus of the UPS system. During normal operation, when utility power is available, the VDC will take energy from the DC bus of the UPS and use this to motor or spin the flywheel to its normal operating speed of 37,000 RPM, converting electrical energy into stored kinetic energy. At 37,000 RPM, the flywheel is considered to be fully charged and reduces the amount of energy being consumed from the DC bus of the UPS. The flywheel will continue to maintain this speed while the utility power is present. Should the utility power fail due to maybe a lightning strike or other reason, the input power to the UPS will be lost, and the UPS rectifier output DC voltage will decline rapidly. The VDC, which is constantly monitoring the DC bus, will sense that an outage has occurred and will instantaneously start to convert the stored kinetic energy in the flywheel into DC electrical energy. This electrical energy is used by the UPS inverter to continue to supply uninterrupted, clean, and stable AC power to the critical load. While the flywheel is providing the backup energy to the critical loads through the UPS inverter, the ATS waits a couple of seconds after the utility outage occurs to confirm that the utility power has indeed failed and is not simply a short glitch. If the utility has not returned within those 2 seconds, then the ATS sends the start signal to the standby diesel generator to start. Once the start signal is received, it will take approximately 5 to 6 seconds for the generator to come up to its operating speed and be able to provide power to the UPS. As the voltage and frequency from the generator stabilize and is available to the ATS will switch from the primary utility source to generator source and provide the secondary source genset power to the UPS. This ATS switching time typically takes less than 1 second, at which time the UPS rectifier will synchronize to the genset source and start ramping up power onto the genset. Depending on the settings of the UPS, this typically will take less than 2 seconds. Now, with the UPS rectifier fully energized, providing power to the DC bus, the flywheel energy storage system will start recharging, again converting electrical energy to kinetic stored energy. The recharge time for the flywheel can be between 2 and 15 minutes depending on the depth of the discharge and the recharge current setting on the system.